Okay, if you got it open there. Okay. Okie dokie. Right, why don't you read it to me, Siba, then, since you have it open.
A layer of oil is present on the horizontal surface of a pond of water. A ray of light traveling in air is incident on the oil at an angle of 42.6.
Okay, let me just draw that. So there's my oil. Okay, and then you have your normal here, and you said it comes in at an angle of
42.6 to the surface normal.
Okay.
Refractive index of air, 1. Refractive index of oil, 1.48. Refractive index of water, 1.33. 1. Determine the angle of refraction of the ray as it enters the oil.
Okay, so that's this angle here. So that's theta 2. So you have sine 42.6 over sine theta 2 equals 1.48 over 1. So then that means theta 2 is sine inverse sine 42.6 over 1.48. So, what's that? You have that answer, Kim?
Yes.
What you get?
27.2.
Okay. Yeah. She seems right?
Yes.
Okay. I'm guessing that the next piece is to get the next angle.
Determine the angle of refraction of the ray as it enters the water.
Yeah. So it comes along here. Now if that angle is theta, then this angle here is 90 minus theta. Yeah? So 90 minus this angle. 8, 9, 10, 62.8. So I can say sine 62.8 over sine theta 3, if we go like theta 1, theta 2, theta 3, that's equal to 1.33 over 1.48. So again, we can get theta 3 is sine inverse 1.48 sine 62.8 over 1.33. Yeah. Ah, ciao, come on. Happy New Year. Year of the Pig. Yes? Okay, you got that? What answer was that? Is that what you got? What's the answer? Sorry, you're right. The answer's different. I made a mistake. The moment you said it, I saw my mistake. This angle, it's my picture, so terrible. Sorry. This is the oil. I drew my angle here. I shouldn't have. Should have drawn it there. So that means here we need to use this angle, which is the same as that angle. So I should never have done this 90 minus. That is still 27.2. So if you just change that Siba to 27.2, do we get the right answer? Now let's see. We're doing exam questions, Chow. What exam was this, Kim?
30.6.
What is it?
30.6.
Is that the answer? 30.6? Okay. What exam was this? 16, 17? 15, 16? version 2. A8. Okay. Right. Is there more to it? Let me guess. Critical angle? Yeah? I knew it. So the last one, the critical angle between the oil and the water, is it? Does it say between what? Yeah, so it's just sine inverse 1.33 over 1.48. Okie dokie. Well, Kim has the answers there, so she can tell us. No! What did you think she said? 16.4? Okay, what's the next question then? In that same exam? Okay, so this is now 1516 version 1 B5? Yeah? Okay, Kim, read me the story.
With the eye of a diagram, briefly describe an experiment who used to determine the critical angle of glass.
So they want the critical angle of glass. You haven't done the experiments yet, but one way you could do it, you can get something like this, a tank, a circular tank, okay? And this tank here is broken in half. And the piece here, this is just empty air, and this piece here can be like solid glass. And then on the tank they mark off the angles. So this is like 0 degrees, and then this is 90 degrees, and this is 90 degrees, and this is 0 degrees. And then there's a little laser here at the edge, and you can actually turn it around. So what you need to do is turn it so that when it doesn't travel through the air, so that when it hits the boundary, it travels along the top like this. So this angle here then is the critical angle. So we could say like this. Now that's one way to do it. If you don't have something fancy like that, the other way you can do it is using paper. So what you do is you take a piece of paper, and I think you might have seen this before. You put like a piece of glass on the paper, and again you do the same thing. You shine the laser through it, and then you use a pencil to draw the lines, and then you can measure the angle. You know, there's a couple of ways to do it. That's just one way. I don't know what they say. How many marks is this? 4. So what you could say is using a what's it called? Let's call it a light box as shown. Move the laser to an angle C that causes internal refraction. Actually, I should just put in that, I should say in here, just about. Just about. Now, you should name everything here. So, in your diagram, this is a laser. This is for measuring angles. And I'll call this just a light box. I can't remember the exact name. And it's made of just some air and some glass then. What do they say in the marking scheme? Too long, yeah, okay. Do they draw a diagram?
Something like that. It has to go this way.
Yeah, but this is another way to do it. So what you could do is you can use the light box to calculate the refractive index and then use the formula sine inverse. This is actually one of the experiments you'll do after the break. You can make a graph where you have sine theta 1 here and sine theta 2, and then you can use this graph to get the refractive index. And then once you have the refractive index, the answer is just sine inverse 1 over n. So, I mean, I don't know, there's like 3 or 4 ways to do it. You probably want to learn the way that has the least words in it. So the way that has the least words in it is this. I can't think of anything shorter to do. I have that in the office, by the way, that light box. You can move the laser around it, so you'll get to actually use it after the break. Yeah. Is that okay? You can do the same thing with other materials, but it works best with glass because the glass doesn't move. You see, you can do the same thing with water. But the problem when you're doing this experiment with water is the water moves, so it's kind of hard to measure the angle. Okay, what's the next part, Kim? Like that?
Yeah.
Let me guess the question. What's the refractive index? So 40 sine 41.81 equals 1 over n, and that one is for the air and that one is for the glass. So n would just be 1 over sine 41.81. What's that, like, for about 1.3? Oh, okay, 1.5. How many marks is that now? Must have only been like 1 mark, 2 marks. 2 marks, okay. Okay. Right, what's the next part now? Okay. What is the refractive index for water in the question? Okay, so it's just that. $62.5. 2 marks? 1 mark? 2? 3? 3? Are you sure? And we got it right? It's kind of amazing. Okay, whatever. Right, what's next? In a what experiment? Okay, good old Young, yep. Oh, just a sec, better plug this in. Don't panic. Need to buy a new battery. My battery's nearly broken. Okay, sorry, Kim, go ahead. 458 nanometers?
Yeah.
Okay.
Used to illuminate the narrow, let's say, 2.35.
2.35? Okay.
times 10 to the 4 minus 4.
10 to the minus 4. Right. So that's 335 micrometers then, okay? Okay, what's next now? Oh yes, what's the question?
The distance between the double slits and the screen is 0.915.
Okay.
Determine the distance between the bright fringes seen on the screen.
Alright, so that's S. So S equals lambda d over d, which is 438 times 10 to the minus 9 times 0.915 over 3.35 times 10 to the minus 4. And that is the answer. Okay, so 1.2 millimeters. Great. How many marks was that, Siva? Does it say? Okay. Right, when you're ready, Kim, you can read out the next question.
The screen is moved further away from the bubble slit and the distance measured across 13 fringes is 40.6.
For 13 fringes, it's
30.
30? Oh, 30 fringes, sorry. 30 fringes, yeah.
Is 40.6
40.6
millimeters.
millimeters. Now, before you continue, what that means is the distance between two of the fringes, you have to, 30 fringes, so divide by 30. So 40.6 over 30 millimeters. Okay, 1.353 millimeters. Right, continue, Kim.
Determine the distance that the screen has been moved.
Ah, okay, so everything else is the same except for this. So let's see. We have 1.353 times 10 to the minus 3, that's the S, equals lambda times d over small d. Right, so we just want to get this guy now. So that is equal to 1.353 times 10 to the minus 3 times 3.35 times 10 to the minus 4 over 438 times 10 to the minus 9. So it's a little bit bigger. It's like 1 meter or something. 1.03. Is that okay, Kim? Yeah, what's next?
The answer is wrong.
My answer's wrong? What is the answer?
0.12.
They wanted the D, didn't they?
That's right.
Don't worry me. Okay. What's next, so?
Will you have to substitute?
There's more? What was the... Oh, they want to know how much it's been moved. So, should I subtract the two? So, what was it previously? It was 0.915 to 1.03. So that means it was moved, whatever the difference is there. So what's that? 0.115. So that's what you were saying, Kim, 0.12 meters. Yeah. Okay, what's the next question now?
In such an interference experiment, it is important to ensure that the light from the opposite is coherent. Explain the term coherent.
Okay, so coherent means that the two light sources are in phase. Do you remember in phase? In phase means constant phase difference. And have the same wavelength, isn't it? I think. What did they say in the market scheme?
Coherent waves have a constant phase difference.
Oh, so they didn't even bother with the same wavelength part. They just said the two light sources are in phase. Okay. Yeah. What's next?
What diffraction pattern has 800 lines
Per millimeter? Okay.
Rate of light to wavelength 438 nanometer. And in this instance, per minute to operate in 0 days. Determine the spacing of the lines through on the wavelength.
Oh, so the first part is just to calculate this. 1 millimeter divided by 800. So that's fine. And then what's the next part?
Determine the angle of diffraction for a second under spectral light.
N is 2. Okay, so that's n lambda equals d sine theta. And then we just calculate the theta. So theta would be sine inverse 1600 times 438 times 10 to the minus 9 over 10 to the minus 3. Yeah, so what is that angle now? Say again, Matt? Okay. Yeah? Is there more? Okay, what's next?
Show that this is the maximum order of diffraction that is observed.
Interesting. Okay. So, you know that n lambda equals d sine theta. So that means n lambda over d equals sine theta, which must be less than 1. So that means n lambda must be less than d. So that means n must be less than lambda, d over lambda. D over lambda equals 10 to the minus 3 over 800 over lambda. So that's times 438 times 10 to the minus 9. Right? No, I've done something upside down, didn't I? Yeah, sorry, what am I doing? What am I doing? That should be divided. Divided by that. So, what do you get here? You get something like 2 point something. 2.8, whatever it is. So you can see that the biggest the n can be, the maximum is a 2. Yeah, which is what they asked us to show. Okay. Oops, sorry. Is there more? Is that the last part? Okay. Which bit confused you? What was the tricky part?
I understand the differences.
continue now. I think we'll look at the next chapter. We'll start the next chapter. Yeah. Unless, sorry, was there another section A question? There was another section A question, wasn't there? You said you did 2 section A's. It was okay? Yeah. Right. What's wrong? She's what? Nah. She's just hungry. She didn't have her biscuits yet.